Welcome back to the Mayhem Lab. In this episode we have bacon, tinfoil, and water coupled with some Bluetooth.
Alright, today here on the Mayhem Lab, we're going to do some kind of wireless 2.4 gigahertz kind of myth busting. So how this came about was, Michael and I were talking about Faraday cages and kind of just transmission, and I learned that kind of the reason that 2.4 gigahertz is used for all these devices, well, that's what the FCC approved for kind of everybody's use. Way back in the day, the reason the FCC approved that for everybody's use, for just kind of open, is because that's the frequency that microwave ovens use. And there's a specific reason for that. The reason that microwave ovens use 2.4 gigahertz is because that frequency of radiation heats water, heats tissue like meat and like bacon. And so it's a strange combination that we've gotten to the point where they started with the frequency that can heat water, meat, things like that, is now the frequency that we use for all these devices that we carry with us because of that connection. So we want to do some projects to kind of figure out and just look at like how good are these different materials at stopping or blocking signals like that. And then so that's going to be our first project here, is just looking at building a Faraday cage with water, because that's the 2.4 gigahertz, that's what it's for, that's what the microwave oven's at. Bacon, because that's our human analog, would human tissue stop the signal. And then we're also going to use aluminum foil, because that's another thing we've heard makes a good Faraday cage. Mm-hmm. That's what we're going to do.
So just to recap, so we're going to talk about the 2.4 gigahertz range and stuff, and I think one thing I wanted to touch on is the reason that the microwave works is the 2.4 gigahertz range basically agitates, correct me if I'm wrong, but it agitates the molecules of water, and it basically makes them wiggle and absorb that radiation, right? So that's why we feel water or anything else that you can warm up in a microwave that would take the heat, as it were, take that radiation, should work as an appropriate Faraday cage. So that's where we kind of came up with the idea of water, bacon, anything else. Obviously, tinfoil should never go in your microwave.
Yeah. And a cool corollary to that, I learned when I was working on trying to build some Wi-Fi antennas, is if you have a material that you want to use to build an antenna and you want to know if it's going to block or interfere with the signal, put it in the microwave. So when I was building some PVC ones, took a chunk of the PVC, put it in the microwave. If when you microwave it, if it gets hot, that means it's absorbing some of the signal. You don't want to use it. If it stays cool like your dishes do, it will just be like a window, transparent to those microwave frequencies.
Yeah, that's a good point. So what do we want to do first?
So the first thing we're going to do is look at how good are these things at blocking this signal. And to do that, we've built a little kit here. We've got a USB battery pack, which is powering a TP-Link travel router, kind of the guts of it. And connected to that, if you saw our last episode, we've also got a little Bluetooth adapter, Bluetooth to serial adapter. So I can connect to the serial console of the mini pointer of the router board here through that adapter. Mm-hmm. And this is going to let us do two things. We're going to be able to test the Bluetooth connectivity, and I'll do that from my cell phone. And then we're also going to test the signal strength. We've got this router set up as an access point, and Michael's got an app here that's going to monitor that signal strength as we basically do different things with this.
There is an app for that.
Yeah. And so the first thing, let's do the aluminum foil first, because that's the thing we've heard is supposed to work pretty well.
Right. So what I've always heard is that you need the heavy-duty aluminum foil, which you can find at any grocery store. So slice off a chunk of that.
Yeah. And right now I'm connected to the Bluetooth module, and you're showing like
so
super strong 40.
Yeah. I don't know if you can see that, but we've got pretty much solid signal strength on that negative 40 dB. So I'm going to go ahead and throw this in some aluminum foil.
Make our little router calzone.
Exactly. It gets me, you gotta have lunch. I'm getting hungry. Calzone sounds good. I don't know about a router one though, but all right. so there we go. It's inside of its little casing. As we can see, we've dropped it down to pretty much nothing.
Yep, and I just lost my connection to the Bluetooth device. So aluminum foil works pretty well.
I want to rip that, just rip a hole in it. Because you notice one thing I did is I crimped all the edges shut.
Look at me, not able to rip aluminum foil.
He-Man. So now it's come back up.
Tiny little crack, yep.
You know,
it takes a little while.
there is a little bit of a delay in the measuring of the app. It checks it every couple seconds, I think. But we might still have a wireless leak in there somewhere. So there we go, it's falling. So pretty cool. Clearly aluminum foil works. So if you want, you could, carry around a little bag of aluminum foil, put your Wi-Fi devices in so nobody else can see them. Alright, so that was kind of a no-brainer, I think.
So the next thing I wanted to try out was water. And we've got a couple different ways to do that. First, I've got a bag of water in a box here to kind of start that.
Nothing special, just very cold water.
Yeah, I was trying to freeze it, never got frozen, but that's okay. So I'm going to put everything on top of that water.
Okay, and we're still getting, solid signal.
Actually, I'm going to put the battery fix. There we go. And just put one bag of water on top of it. So there's probably about 1.5 inches of water completely surrounding any part of that's got an antenna on it.
It definitely made an impact from a wireless an 802.11 standpoint. Not dramatic. Dramatic?
Dramatic, yeah.
Dramatic, that's not a word, dramatic. I'm just making up stuff. So now it's fallen all the way off, actually.
Okay.
It's fluctuating.
Yeah, and I'm connected in theory to the Bluetooth module, but it took a couple tries, so apparently it's pretty weak if at all. But I just did an LS command and I got the response back.
So that's about 1.5 inches of water
Yep.
in a 360-degree view. So now we'll add another
Bag of water. Because the top was
1.5
probably the narrowest part. Still connected here.
Drop it
go
again
above
a
it.
little bit. I'm down to about 73, 74. Now we're back up to 60.
Apparently it takes quite a bit to block it.
Yeah, now it's going back up.
Okay. So it doesn't work that well. It actually transmits through the water better than I thought it would.
It does.
Maybe we were kind of short on some of the sides here. Maybe, yeah.
Those other 2 bags on there.
Why they were to get signal underneath it though. Oh, and I'm leaking water here somewhere.
Yeah, unfortunately.
Still pretty strong.
Still
But I
pretty
think it could be
strong.
reflecting off the floor. Well, let's try our bucket of water. See what happens there.
Oh, did we have that one?
Oh yeah, this was ice.
So we had a package of ice.
So drop this one in the box.
It was in the box.
'Cause in theory, ice doesn't work as well as water, but apparently we're not even getting a good signal or a good block from our water. So I think the ice is going to do much better than the water did, or worse. Yeah. Hopefully it's not too loud by our microphone now.
Oh yeah, I didn't think about that. Sorry to blow your eardrums out.
Yeah, I'm still talking to it. That's funny. Not working very well to block it. Definitely made it a little more difficult.
We can go through it in the river.
Yeah. Wow. So your signals go through quite a bit of
Yeah, quite a bit of water.
water.
Wouldn't have called that because you can heat up water fairly well in the microwave.
Mm-hmm.
So wouldn't have thought of that.
Yeah.
It did make an impact, but not really as much as I thought it would. So
I'm gonna go ahead and.
dump it in a bucket of water.
Oh, see, that dropped it there a little bit again,
It
but
did.
not very much.
Go all the way in. Oh, it went down a little bit more.
So it works, but you need quite a bit of water to try and block something like that.
See how much water we can.
Stack around it. Yeah, and it's still just a kind of a partial.
I think the problem. Oh, there you go. And I think the problem is, it's a 360-degree signal, right? So you have to be really
Yeah.
diligent about building something that's going to block, the entire signal surface
Yep.
of all 360 degrees.
Well, I'm not holding much hope for our bacon now with.
I don't know. I think I would hold out hope. Oh,
Not
it
there,
was,
yep.
was there for a minute.
Well, the bacon's kind of working though. Like if I pull the bacon off.
Wait for it.
It's up in the green without the bacon. Interesting. Not much difference.
Let's try this. Stick that in there, a nice little cavity. Hey, it got stronger.
Nice.
We've improved the signal strength. All antennas should be made from bacon. So yeah, it's definitely having an impact, but not very much.
I actually haven't lost my connection to Bluetooth this whole time, as far as I can tell. Which is pretty impressive for Bluetooth that it can go through that much.
Yeah. I went down to nothing.
Okay. Yeah. I'm still connected on the Bluetooth.
It seems to keep fluctuating.
Yeah. There, it's back up.
Mm-hmm. It's definitely having an impact, but it's definitely not significant.
All right. So, whoa, that was almost fun. So apparently that's interesting because our next part of this project, we're going to do some testing to see if the signals from Wi-Fi and Bluetooth actually can heat our human analog, the bacon. So that's our next project. Let's go ahead and do it and just see if it does it. But
Yeah.
I think based on this, like the signal transmits through this kind of tissue pretty quickly. So
Does.
it'll be interesting.
All right.
We'll be back in a minute. We're back. We're here for Act 2, where we are testing out how harmful Wi-Fi and Bluetooth might be to bacon, our human analog. So we've got kind of a interesting rig set up here. What I've got here is an Arduino, and it's connected to 3 of these little temperature sensors. I've soldered one on to each like wire lead here. They're I2C, so they all run kind of in on the same bus, on the same I2C bus. We've got a little screenshot of what they're showing here, and so our 2 bacons that we've already wrapped up. Now we're capturing. Our 2 bacons that we've already wrapped up are at 19 and 18 degrees Celsius, and then the one I'm holding is at 28 degrees Celsius for my body temperature. I'm just going to let that go and it'll go down. So what this is going to let us do is set up 3 different tests where we're going to see what heats bacon more. We've got a control that's just going to be wrapped in tinfoil as a Faraday cage to block any signals coming in.
Because we know that works.
We know that works. We're going to have our actual irradiate as best we can, where we're going to set it right on top of a little wireless access point, right on top of a Bluetooth adapter. We're going to be streaming video from from a tablet here to a server. So we're going to run it for some minutes with as much kind of Wi-Fi and Bluetooth 2.4 gigahertz activity as we can. And the thirds are going to be our control. I think I already talked about that.
Yep.
Did I talk about the flashlight? And then, okay, so actually our third then is going to be a flashlight, because I wanted to see, okay, if we're illuminating it with Wi-Fi and Bluetooth, how's it different if we illuminate it with just incandescent light? So I've got a mag light here with an incandescent bulb to see if that warms the bacon more than the radiation does.
So just
So
start a movie.
And I'm going to, let's see, I'm going to start wrapping our control in tinfoil if you want to start getting the bacon one ready.
So what we did for the bacon, put this over here, movie going. Alright, so for the bacon, as Kevin said, we've got the temperature sensor here soldered all up real nice, and got, just going to wrap it in some saran wrap, cling wrap. So we don't get the sensor dirty or short circuit it with bacon. I heard once that you're supposed to rub bacon on all kinds of things, and I don't know if temperature sensors were one of them.
Got some toothpicks there, good.
We'll see if anyone actually understands that reference. All right, so that, some toothpicks. So there. All right, so as the temperature has cooled down on this one now, since I've wrapped it in cold bacon.
And they might not all start at the same temperature, but we're really looking for the temperature change, and if they're a few degrees off, that shouldn't be a big deal.
Right. That's an important part. It's a relative test to what each one started as, to what they're going to. So throw this one in there.
And I stopped doing that because it was loud.
Yeah.
We learned our last show you actually have to crimp it up pretty good.
Mm-hmm.
Extra shielding there.
Okay. So that's,
And our temp
smudge
sensor's
the
looking
bug.
pretty good. That one's down to about 20 degrees. We're going to set it
Okay.
right on top of this. And I'm going to turn on the mag light, illuminate that bacon,
So we've got our,
and I'm going to reset our counter so this will actually count seconds for us. Alright, second number one. We got 19 degrees on the flashlight, 18 degrees on the control, 20 degrees on the Bluetooth and Wi-Fi. Try and get that right in there too, maybe. And I can actually make sure there's some Bluetooth traffic by talking to that Wi-Fi from my phone.
okay.
But this is it. Now we wait. We'll probably cut and let it go for a little while and come back and see if anything's changed.
See you in a few minutes.
We're
All
back. Sorry.
No, that's all right. So we're back. We've got what, about 20 minutes? We said.
20 minutes, enough time to cook and eat some bacon.
I had to do something with it.
We've had the rig running here. We've had the video running. You see, we changed this up a little bit just to get the make sure that there wasn't outside air affecting the bacon, and also to make sure that the signals were kind of hitting the bacon as best it could.
Mm-hmm.
We'll swap over here to the screenshot of what we have. So sensor one right here was the Maglite flashlight, and that's gone from, I believe, 19 degrees to 22 degrees. Sensor 2 was our control, and that went from 18 to 19 degrees, but that might have just been
within tolerance.
Within the error of the sensor, probably. And our Wi-Fi and Bluetooth one has stayed steady at 20 degrees the whole time here.
Yeah.
So
we have tried, like I said, we've got 2 or 3 different Bluetooth devices going. We've got a movie streaming through Wi-Fi. Doesn't seem to be having much of an impact.
yeah. So what can we conclude from that? Well, one of the things we saw in the first half of the show was that you actually need quite a bit of water or tissue or something like that to stop a 2.4 gigahertz signal. So I had thought it would be less of a thick layer of stuff would slow down the signal or absorb more of the signal. So I think part of it is, the bacon may not be absorbing a lot of the signal, but from what we can tell, it's absorbed hardly anything, in comparison to this Maglite flashlight, which actually caused the bacon to heat up. So,
Right.
So from that perspective, the Maglite flashlight is doing more damage, theory, by heating up my hand than the low Wi-Fi signal or Bluetooth signal. The other question that Michael actually asked me was, well, what about, isn't it radiation? Is it just heat or is it radiation? So we looked that up as well. And there's 2 types of radiation. There's ionizing and non-ionizing radiation. So your ionizing radiation is things like X-rays and cosmic rays and stuff from uranium or plutonium or whatever, that actually knocks electrons off of your molecules, off of the atoms, and causes things to mutate. Microwaves, the 2.4 gigahertz, is non-ionizing radiation, so it doesn't actually, cause things to mutate. It doesn't actually knock atoms off of, or electrons off of atoms. It just heats things, causes molecules to shake and vibrate and heat up. And as we saw here, like, as best we could, to some extent, with consumer grade Wi-Fi and Bluetooth stuff, try and illuminate this to heat it. It didn't heat up. So,
Right.
Potentially, the other scary thing from our first one, though, is again those signals penetrate much more deeply into water or tissue than just the surface, like the flashlight would. So there's the potential that you're getting such a low level of heating, but it's also, if it's a Bluetooth headset, it's heating like the middle of your brain, that tiny insignificant amount.
So we need more bacon.
Yep.
Like
bacon helmet,
a
3
bacon
inches thick.
Bacon helmet, 3 inches thick.
Then you're safe.
That we're gonna make.
Next time on the Mayhem Lab.
Thanks for joining us.
Thank you.